This video explain the example for development length. So we have a 750 millimeter by 350 millimeter T-beam supported at supports a 300 kilonewton concentric load factor at the center of its 800 millimeter simply supported span. Based on the bending moment at the mid span, 4 and 28 bars, design moment capacity of 650 kilonewtons are provided. If the flexure capacity of the section when reinforced with 2 and 28 is 325 kilonewton, determining the development length. And there is a second questions that we're going to the solve this. I'm not reading it, but when we solve it, we will extract the informations. And the concrete compressive strength is 25 megapascals, and there is a 30 millimeter cover all sides of the R10 stirrup. So the stirrup is provided R10. Now we are going to use AS3600 on section number 13. The development length equation is given. Now let's solve these examples where development length is just length that reinforcement will be provided for transferring the design force from, let's say, steel to concrete or concrete to steel. So that is the length which is embedded in the concrete. We call it that development length. That's just a quick definition of the development length. So we have given beam 750 by 350 millimeters given in the questions as T beams. It is 8 meters long and is simply supported, and the concentric load 300 kilonewtons applied at the middle, right? So now development length LSTY is taken from the 13.1.2.2 basic development length. The equation is given here. These notations here. Now in here we have K1 is the depth factors depending on the depth of the concrete from the reinforcement. K2 is the bar diameter factors. K3 is the cover and bar spacing factors. dB is the bar diameters, and FSY is a bar yield strength, and FC dash is concrete compressive strength. So we using these equations to calculate the deformed bar under the tensions. Now we can solve these problems one by one, extracting the factors. K1. Now K1 is given either 1.3 or 1 depending on the horizontal bar with more than 300 millimeter of concrete cast below the bars. Now I have given the figure here. When the concrete below is less than 300 millimeters, we take K1 equal to 1, and the concrete which is more than 300 millimeters, then K1 equal to 1.3 millimeters. So for this case, if I give you the figure here, we have a concrete cover is 30 millimeters. As you can see, the concrete is 30 millimeter cover. So we have a less than 300 millimeters. The concrete is 30 millimeters here. So we have less than 300 millimeters. So K1 equal to 1. So we take K1 equal to 1. Now equation for K2 is 130 minus dB over 100. So I just written here, and the diameter of the bar is 28 millimeters is given here, and 4 and 28 bars. So 28 stand for diameter. So I just substitute that one, give us the get the 1.04 is a K2. Now K3 is required some calculations, which is 1 minus 0.15 CD minus dB over dB. Now it is a straight bar and it's in the T-beam, so we need to use the figure to calculate the CD. So if you just turn over the page, on page number 183, we have a definition for calculating the CD, where is basically depending on your concrete covers and the spacing between the two reinforcement. So CD will be taken as minimum of A by 2. C1 is the distance side cover, and C is the bottom cover. That is C here, and we have various options given, but we are looking for the option of beam and straight bar. So therefore I choose the figure A. So I written this CD equal to minimum A by 2, C and C. So minimum, now I need to calculate A. Now I have drawn some figure here, which is just a magnified view of this bar here. We have given 30 millimeter cover given in the questions. So that is 30 millimeter cover given in the questions. we have a stirrup 10 meter. So this stirrup is 10 meters, R10 stirrup, so that is 10 meter. Then we have a bar which is 28 millimeters, so that is 28 millimeter, and distance A is the face of this bar to the next the face of the next bar. Okay, so that is the A. So this is A, 28, A, 28, A, 28, and then you have 10 millimeter and 30 millimeters, right? So if I can write it down here, this one is 10 millimeters and this one is 30 millimeters. So my question is to calculate the small a. Now to calculate the small a, I know this is 350 millimeters given in the questions. This one is 350 millimeters given in the questions. Now I can have 30 plus 10 stirrup plus 28 bar diameters given in the questions, plus a plus 28 bar diameter plus a plus 28 plus a plus 28 plus 10 plus 30 equal to 350. You can work it out. This is the simplest way I can find it out, how to calculate this a. There are various methods, or you can use these plus and minus methods the way you like it, but this is the simplest one, just the addition and subtraction. So if I just plus 30 plus 10 plus 28 plus 28 plus 28 plus 28 10 plus 10 would give me 192 millimeter plus 3a. So a plus a would be 3a equal to 350. Bring this 190 across, give us 158, and divide by 3 will give me 52.7. Now I substitute the value 52.7 divided by 2. Now C1. Now if you look at the figure, C1 is the distance from the face of the reinforcement to the edge. Now over here C1 can be taken as this concrete cover 30 plus 10 is a stirrup diameter. So we have 40, and C is this distance because the stirrups also go along this side. So this C will be also taken as 40 millimeters. As you can see here, we have 30 cover plus 10 stirrup, so C equal to 40. If I just simplify, that will give us 26.33, 40 give you 26.33 millimeters. Now that is the CD. Now we know dB is equal to 28 millimeters, that is given in the questions, bar diameters. And if I substitute these, if I get these K3 equations from this standard, which is 130, K3 is 1 minus 0.15, 26.30, so this is the equations given in the K3. If I substitute this value CD, we just found CD 26.33. We found 26.33 in the last equations. Take away the bar diameter 28 over 28, it gives me K3 equal to 1.009. Now but Australian standards has given the note here where K3 should not be less than 0.7 and should not be greater than 1. If it is greater than 1, you should take it 1. If it is, the calculations give you K3 less than 0.7, you should take it 0.7. And if it is K3 between these two values, you should take the K3 as it is. But here the calculations give me 1.009, right, which falls outside of this category. So I take K3 equal to 1. Now I have all the parameters to calculate this basic development length for deformed bar in tension. So we have these equations which is given here. I substitute the value 0.5 K1. I think we calculate the K1 is equal to 1 here, times by K3 we just found 1. Yield strength, the N bar diameter has a 500 megapascals. I think I saw you that one in the previous video. We used that 500 megapascals bar yield strength, and then there is 28 millimeters bar diameters given in the questions. And K2 we found 1.04. And times by concrete strength would be 25. It's give me 1346 millimeters. Now when you put it on the drawing, we can't just give a 1346. We generally put this rounding number 1350 because the builder will not going to go and put 13.40. We generally provide the rounding number, so you can provide 1350, but for calculations we can just use 1346 millimeters. Now We need to do one more check here. That check is required that when you calculate your basic development length, it should be greater than these equations given here. So I just written that equation here, which is basically 0.058 times the yield strength of the bar, which is 500 megapascals. K1 we calculated 1. K1 was 1 here, times by the bar diameter 28. It's the calculations give me 812 millimeters, so which is less than 1346. 1346 is greater than 812 millimeters, so it is okay. We can take 1350 millimeters. Now 1350 is 1.3 meters. Almost you don't have that space available for this one. You can see this in these figures that you need to have a space of 1346 millimeters. Generally you don't have that much space to provide that development length, so we just generally provide the hook. I think the Australian standard has provided the detail about that hook. I think if you go on page number 187, they say that if you are using the hook, you can have a distance from this face of the hook. You can provide 0.5 to half of this length. So I just divided by half to get these 675. So if your architecture don't provide this 1346 millimeters room here, we can just provide the hook with the 675 millimeter development length. And I think that's it. So and 1346 millimeter is coming from here that we just calculated for the straight bar. Thank you very much, and in the next video we can solve the next part.